All right. Part B, again, the directions are to find the general solution to the differential equation. And then we find the particular solution which satisfies the initial condition right there. But of course, to begin, we need that general solution. So we're going to look at the same example that we saw earlier, y prime equals 6x minus 9x squared over 2y plus 4. And we did see before that how this is separable, even though it doesn't quite appear to be at first. Okay, so where do we go from here? Again, the idea to solve this thing, our method is to get the y's on the left, the x's on the right. In order to do that, we need to think of our derivative y prime as dy over dx. So that'll be my first step, rewriting it this way. Then I will multiply my 2y plus 4 over there. I'll multiply my dx over there. And I'm just going to go ahead right now. At the same step, people usually just do this all at once. When I multiply my dx over, I'm just going to throw integral signs in that same step. So I'm integrating both sides as well. Okay, and then, well, we just got to integrate and see what happens. So when we do that, hey, y squared plus 4y, 3x squared minus 3x to the third, and if you remember, only add your c on the x side. Now it turns out we need to stop right here. It's an implicit solution. It's not solved for y, but if you want to solve this for y, well, you can knock yourself out with that. I'm not going to bother y squared plus 4y to try and isolate y. Yeah, let's not go there. This will be plenty good for us. So we've got the general solution. It has the arbitrary constant. Okay. But of course, the second part of our problem is to then apply it to the initial condition, which they told us was y of 2 equals 1. So we're going to plug in that value of x and that value of y back up here and find the value of c. Plugging in 1 for our y's, plugging in 2 for our x's. Gets us to here. Let me just kind of draw this up a little bit. And okay, this cleans up pretty well, right? We've got 5 there on the left. And that'll turn out to be negative 12 plus c on the right. So that's pretty good. Oh, looks like I'm continuing on the next page. When we solve, we've got 17 equals c. So we're going to take that value of c and put it back in to our solution. There it is right there, plus 17. Y squared plus 4y equals 3x squared minus 3x to the third plus 17. That's the particular solution that satisfies the initial condition. It'd be kind of nice if we could graph all these things in Desmos, right? We could graph this particular solution. Man, I wonder what that looks like with all the y squared and the x squared, like kind of elliptical or something. It's got a cube in there too, like ooh. And we could graph it with c and see what Desmos does with that, giving different values of c, and we could graph it with just plus 17. We could see that one member of the family of solutions. Anyway, I don't want to do that here. I don't know how to do that here in Desmos. I'll just invite you to do it on your own. A lot of fun. Okay, so I've got one more example in this section before we close it up. Oh, I'm telling you too much. Find the general solution. Okay, so I wanted to present you with one more of these solving a separable equation. It turns out there's a couple of problems, one or two in the homework, where it's not clear at all how exactly this thing is separable and how to separate the x's and the y's on the left and the right. So this is something that is of that style. X y squared minus x times y prime equals x squared y minus x squared. Wow, there's a lot going on. How are we possibly going to get all the y's on one side, all the x's on the other? And I might have given it away earlier when I didn't have my page in the right place, my cover sheet here. You think, hey, you know what? Both of these have an x. Both of these have x squared. What if we were to factor? And yeah, that's the key. So if it's not clear right away what to do, maybe you need to factor and then start dividing things, that sort of thing. So we'll factor these both sides first, then we'll be able to do it. So if we factor the left, we can factor that x out. We factor the right, we can factor that x squared, and then we're going to start moving stuff around. So we'll divide that x. I'm going to leave the y prime where it is. And then obviously if anything simplifies, then we'll go for that as well. So it turns out, this numerator here is a difference of squares. That will factor nicely and cancel a term down there, leaving you with y plus 1 dy over dx. And of course the right side is x. So hopefully I'm not moving through this too quickly. Lastly, it really looks a lot simpler now. What are we going to do? We're going to multiply that dx to the other side and integrate. Multiply the dx over. Throw a couple of integral signs in there. And we're one step away from an implicit solution. We got it, right? 1/2 y squared plus y, 1/2 x squared plus c. The plus c only on the x side. There's our implicit solution. Now, we're not going to solve this for y because we got that same issue. So we don't want to bother with an explicit solution. But one thing you might notice is, hey, there's a 1/2 there, there's a 1/2 there. What if I multiplied everything by 2? Multiply by 2, multiply by 2, multiply by 2. The c also got multiplied by 2, but hey, 2 times a constant, 2 times an arbitrary number is just a different arbitrary number. So even though we multiply by 2, I'm still going to write plus c because it's arbitrary. Okay, so either one of these answers will do. This one looks a little bit nicer though. Well, that's the end of 9.2 separable differential equations. We're going to learn another form and solving technique in 9.3.